All right, part 2. So this is factoring trinomials when a is bigger than 1. So we're going to have a different number here. What we're going to do first, take that number. We don't want it there, so we're going to multiply it by this number. And we're going to rewrite. So we're going to rewrite this as p squared minus 2p minus 15. And we're going to factor that. If we have a negative number here, that tells us one's negative, one's positive in our answer. So our factors of 15, that's going to be, we could have negative 1 times positive 15 or 1 times negative 15. And our sums here would give us 14 or negative 14. Okay, we're looking for negative 2. Second factor that we have is negative 3 times 5 or 3 times negative 5, which gives us the sum of 2 or negative 2. And we do want negative 2, so we're going to use the factors 3 and negative 5. All right, we're going to write those out. So we have p plus 3 times p minus 5. But we can't forget that at first we multiply by 3, so now we have to divide both of these by 3. So we really have p plus 3 over 3 and p minus 5 over 3. We're going to simplify where we can, which is here. We're going to end up with p plus 1. And when we can't simplify here, or if we already did and it's still a fraction, we're going to take this bottom number and move it to the front of the p. So we end up with 3p minus 5. Okay, so this right here is going to be our final answer. All right, next one. We're going to take this 2, multiply it by our last number, and we're going to rewrite. So we have n squared plus 3n minus 18. We're going to factor this. We've got a negative here. It tells us one's got to be negative, one's got to be positive. So our factors here, negative 1 times 18 or 1 times negative 18. And our sums for those would be 17 or negative 17. We're looking for positive 3. Next, we would have negative 2 times 9 or 2 times negative 9, which would give us sums of 7 and negative 7. Next, we would have negative 3 times 6 or 3 times negative 6, which would give us sums of 3 or negative 3. We want positive 3, so we're going to use the corresponding factors, negative 3 and 6. So we're going to write those out. N minus 3 times n plus 6, but we can't forget we have to go back and divide by what we multiplied with. So we're going to have n minus 3 over 2 and n plus 6 over 2. And we're going to simplify where we can, which would be this one. So we have n plus 3. And where we can't simplify, we take our denominator and move it to the front to n minus 3. That there would give us our final answer. All right, number 3. We're doing 3 times 4 and rewriting n squared minus 8n plus 12. We're looking for a positive 12, but a sum of negative 8, which tells us both of our numbers are going to need to be negative here. So our factors are going to be negative 1 times negative 12. It's going to give us a sum of negative 13. Negative 2 times negative 6, which is going to give us a sum of negative 8. And that's what we want, so we'll use these two factors, negative 2, negative 6. N minus 2 times n minus 6, and we're going to divide both of our numbers by 3. N minus 2 over 3 n minus 6 over 3. And we're going to simplify where we can. We can simplify this down to n minus 2. This one can't be, so we're going to take that 3 and move it in front of the n. 3n minus 2. That becomes our final answer. Five times 12, that's going to give us 60. So n squared plus 19n plus 60. All positives here. That makes factoring a little bit easier. All right, so our factors of 60. And we're looking for a sum of 19. We're going to have 1 times 60, not going to give us 19. We're going to have 2 times 30, again, not 19. We're going to have 3 times 20. Okay, I'm going to kind of come up here now, just so we have enough room. We have 4 times 15. And there's our 19. All right, so since we're going to use 19, since that's what that says, we're going to use our factors of 4 and 15. N plus 4 times n plus 15. We're dividing it by 5. N plus 4 divided by 5. N plus 15 divided by 5. We can simplify this one to n plus 3. This one, we take our 5 and move it to the front. 5n plus 4. Final answer is 5n plus 4 times n plus 3. Two times 5, that's going to give us 10. So v squared plus 11v plus 10. Again, we're all positive here. That's nice. Factors of 10. And we want their sums. So we're going to have 1 times 10. Gives us a sum of 11. Well, that's what we're looking for, so we're using these two factors, 1 and 10. V plus 1 times v plus 10. But we can't forget we're dividing it by 2. V plus 1 over 2. V plus 10 over 2. Simplify here to v plus 5. And here we just need to move that 2 up front. 2v plus 1. Final answer. Two times 2 is going to give us 4, so we have n squared plus 5n plus 4. Again, all positives. This is very nice. And our factors are 1 times 4. It's going to give us 5. We really don't even have to go any farther because that's what we're looking for. So if we see 5, we're going to use the factors 1 and 4. Start our process of our answer. N plus 1 times n plus 4. Can't forget we're dividing it by that first number. So we really have n plus 1 over 2, n plus 4 over 2. This is going to simplify. We get n plus 2. And this doesn't, so we take our 2 and move it up front. 2n plus 1. I've allowed you to skip number 7. It's just working with some numbers that are a little bit bigger. And number 8. So number 8 is going to be a little different than normal. When you see these big numbers and you really don't want to work with big numbers, there is something that you can do. If you can find a common factor, you can divide everything by that common factor first. So I see 9, 66, and 21. And my first thought is I'm going to want to divide all of these by 3. So if I do that, I'm going to end up with 3k squared. So really we're just taking our numbers and dividing. Then I'm going to end up with 22k. And then I'm going to end up with 7. That makes this a lot easier to work with. So you can divide by that number at the beginning, at first. okay? But when you go to do your answer, you're gonna have to make sure that you put that 3 in the very front. Because if you divided it out at first, of course you're gonna have to multiply it back in at the end. But we're just gonna put it up front, treat it like it's a distributive property that hasn't been distributed yet. From here, we can take it the same exact way as we have been. So we're gonna do 3 times 7, and we're gonna get k squared plus 22k plus 21. Much easier to work with here. We're gonna factor using our box. Everything's positive, so we're looking for positive numbers here. Our factors of 21, we're gonna kind of skip that step here just because 21 times 1 is gonna give us 21 and a sum of 22. So that's pretty easy. We're gonna use 21 and 1. That's gonna give us 21k and 1k, which will sum up to give us 22k. All right, so we're gonna come over here and do k plus 21 times k plus 1. We are dividing it by 3 because that's where we're kind of working backwards now. So we're gonna k plus 21 over 3, k plus 1 over 3. Simplify here, k plus 7. And here we'll take that 3 and move it up in front of the k. 3k plus 1. And then don't forget the very, very first step we did was divide everything by 3. So we're just going to put this 3 out front, like we're multiplying that 3 back in. That one would be our final answer there.